All right, so we're going to hit the last section, which is probability. You're going to want to write down this equation right here. And the way that this is read is the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersect F. Okay, so basically if you think of a picture like this, that's the probability of E happening. This is the probability of F happening. So if I want to know the probability of E or F happening, that means I'm okay with everything in there. But if I just add up E and add up F, then I'm adding up whatever's overlapped, if they share anything. Okay, so I'm going to add up the probability of E plus the probability of F, but I'm going to subtract off their overlap. That way I don't count what's in the overlap twice. So that's what we're doing. We may or may not have to use this, but for the next 12 problems, you're going to want to reference it. So what we have on the first one is E small. When playing American Roulette, the croupier, the attendant, spins a marble that lands in one of the 38 slots in a revolving turntable. The slots are numbered from 1 to 36 with 2 additional slots labeled 0 and 00 that are painted green. Consider the numbers 0 and 00 as neither even nor odd. Half the remaining slots are colored red and half of them are black. Okay. Assume that a single spin is made. Find the probability of the marble landing on a 0 or on an even slot. So we don't have to do this because there's no overlap. Okay, 0 is not even is not 0. So what do we know? We know that from 1 to 36, half of them are even and half of them are odd, correct? Because 1 through 36. So 18 of those are going to be even. Well, then what's the probability of, hang on, I'm trying to make this bigger. All right, what's the probability? So these are all the evens on the wheel. What's the probability of hitting the 0 on the wheel? There's one of those. So that's the 0 on the wheel, where how many spaces are on the wheel? There are 38 spaces on the wheel, so 19 of them are encompassed in our scenario right here. So if I want to hit evens or a 0, that's 19 possible spaces out of the 38, which is actually a 1 out of a 2. So your probability of meeting these requirements is 1/2. Okay. All right, so let's try another one. We have, go small. All right, we're going to go here. American Roulette, the croupier. All right, so the example of a line bet is betting that the marble will land in a slot numbered 9, 10, 11, 12, 13, or 14. So if I've got numbers 1 through 38, and I'm interested in 9 through 14, okay? So I'm interested in 9 through 14. So here's what we're going to look at. I've got the numbers 1 through 38. I've also got 0 and 00. So how many, 36, sorry. So how many total spots do I have? I have a total of 38 spots on the roulette wheel. Well, my line bet says I'm okay with getting 9, 10, 11, 12, 13, or 14, which is 6 of those options. So that's going to reduce to, I can kill a 2 out of both of those. So 6 divided by 2 is 3. 38 divided by 2 is 17. So the probability is 3 out of 17. Okay. Minimize. Next. All right, a pair of dice is rolled. Find the probability of rolling. A sum that is not more than 4. Okay, a sum not less than 3, and a sum between 5 and 10 exclusive. All right, so I'm going to pause this and I'm going to find a chart. Hang on. Okay, so I ran out and I found this online. These are our options. So dice A, which should be die A, because that's the singular. I can roll a 1, 2, 3, 4, 5, or 6. On dice B, I can roll a 1, 2, 3, 4, 5, 6. So if I roll a 1 and a 1, the sum is 2. Okay, if I roll a 1 and a 2, the sum is 3. So my question is, how many possibilities are there at first? Okay, there's 1, 2, 3, 4, 5, 6 by 6. So there's 36 blue numbers here. Okay, so now what are my specifics? I want a sum that is not bigger than 4. So not bigger than 4. I want a sum not less than 3. and I want a sum between 5 and 10. All right, so I've written this down, so we're going to make this bigger for a second. So I want a sum that is not bigger than 4. In other words, I'm okay with 1, 2, 3, or 4. I pause for a second. If it's not bigger than 4, okay, so I don't want it bigger than 4, which means I do want it less than 4. All right, so I'm okay with rolling a 1, I'm okay with rolling a 2, I'm okay with rolling a 3 or a 4, and those are the sums that I am okay with. So when I look at this cool little chart thing, you go away. All right, so of these blue numbers, how many of them sum, or how many of them are a 2, 3, or a 4? Well, there's 1, 2, 3, 4, 5, 6. So 6 of the 36, or 1/6, meet that requirement. Okay, so 6 of the 36, 6 of the 36, or 1/6 meets the requirement. Okay, so a sixth of the time, you're going to roll a sum that's either 2, 3, or 4, because you can't roll a sum of 1. All right, I don't want it to be smaller than 3. I do not want it to be smaller than 3, which means I do want it to be 3 or bigger. I do want it to be 3 or bigger. Well, there's only one of them that doesn't work. So if one of the 36 doesn't work, then 35 of the 36 does work. Okay, 35 of the 36 does work. So 35 of those 36 options will work. I want this sum to be between 5 and 10, and it says exclusive, which means don't use the 5 and don't use the 10. Okay, so when I look at this, I want it to be between 5 and 10. So I can't use this row, or this diagonal, but I can use this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So don't use the 5s, don't use the 10s. So I get 20 out of the 36. Makes that work. And 4 goes into both of those, so I'll have 5/9. 5/9 is what will satisfy those. So those are my answers. All right, so let's talk about some more. Hang on, I'm looking. All right, small. So I am going to do the next one. So Christina Carganova invites 13 relatives to a party. Her mother, 4 aunts, 2 uncles, 2 brothers, 1 male cousin, 3 female cousins. If the chance of any one guest arriving first are equally likely, the probabilities that the first guest to arrive is as follows. I want to know the probability of a brother or an uncle. Okay, so how many brothers are there? There are 2. How many uncles are there? There are 2. So I'm okay with any of those 4 showing up. So the probability is 4 out of the 13. Okay, the probability is 4 out of the 13. What about a brother or a cousin? Well, there's 2 brothers, there's a male cousin, so that's 3, and there's 3 female cousins, so that's 6. So a brother or a cousin is going to be 6 out of those 13. And what about a brother or her mother? So a brother is 2 options, her mother is 1 option, so that's 3 out of 13 that would work. Okay? All right, using a Venn diagram, let P of Z equals 0.51. Let P of Y equals 0.36, and let the probability of the union of Z and Y be 0.74. So find each probability. So let me draw this and then we'll come back. All right, so, oh wait, you can see. Hang on. I made this pretty picture and it's not complete. I'm going to have to redraw it. But what we were given is the probability of Z. So everything in that circle, okay, is 0.51. The probability of Y is everything in that circle, which is 0.36. Okay, and I told you at the start to remember what this formula was. Okay, so I've got the probability of, in our case, Z and Y. Okay, so here's what I know. I know that the probability of Z union Y is going to equal the probability of Z plus the probability of Y minus the probability of their intersection. So Z intersect Y. Well, I know what this is. okay, it's 0.74. So I've got 0.74 equals the probability of Z, I know is 0.51, plus the probability of Y is 0.36. And so now I can solve for this probability. Okay, so I'm going to add those two together. So I got 0.74 equals 51 and 36 gives me 87. Plus the probability, minus the probability of their intersection. Okay, so I'm going to subtract 0.87 from both sides, and I'm going to get negative 0.13 equals negative probability of Z intersect Y, which I don't care about the negative probability, care about the positive probability. So divide through by -1. I found out that their intersection is 0.13. Okay, so they share 1.3. So this is my new and improved picture. I have this amount and this amount. Their overlap, what they share, okay, is going to be 0.13. So of the 0.51, 0.13 is already accounted for. So I need to subtract 0.13 from 0.51, and I get 0.38. So this part is now officially 0.38. So if you'll notice, this part and the part in the overlap add up to 0.51. Okay? So now come over here. I've got 0.13 of the 0.36 accounted for. So I know that this is going to be 0.26. No, it's not. Hang on. My brain is shot. 0.36 minus 0.13 gives me 0.23. Okay, so 0.23 and 0.13 gives me 0.36. Okay, so I know that much. So now what do I know? So this is Z, and this is Y. This is their overlap. This is the probability of something, of both of those happening. Okay, and now I need to know what's left, because this is the universe out here. So remember, all the probabilities need to add up to 1. So at this point, I've got 0.38 plus 0.23 plus 0.13 had better be 0.74. Okay, so 0.38 plus 0.13 plus 0.23 is 0.74. Okay, so that means whatever's not in those two bubbles with the overlap needs to be part of the universe of, oh, that's not going to happen at all. Okay, so that's going to be a 0.26. Okay, so that's a 0.26. So the probability of just Z, the probability of just Y, the probability of what they have in common, or their overlap, plus the probability of something else completely and totally happening, all equals 1. Well, now we can go in and we can figure out the rest of these questions. So I'm going to write them down. Hang on one second. All right, so I have written down our little options here. So here's how we're going to read this. This is the probability of the intersection of not Z and not Y. In other words, the overlap. So we could say it's not in Z and it's not in Y. Okay, the probability of it not being in Z and not being in Y. So it can't be in this circle and it can't be in this circle. So that leaves only the outside part. So that probability is 0.26. Okay, so this is 0.26. This is going to say the probability of not Z union not Y. So this is going to be read as or. Okay, so the probability of not being in Z or not being in Y. Okay, so how is this going to work? This is going to be, well, if it's in here, it's in Z. If it's in here, it's in Y. If it's out here, it's not in either. What it ends up being is just this little overlap part. That's the only place where that Z and Y, and we want not Z or Y. No, I'm sorry, not Z or not Y. Okay, so if it is in Z, it cannot also be in Y. So our answer there is just the little overlap part, which is 0.13. Okay, the next option we have is not Z or Y. Not Z, or we can say Y. Okay, so we want not Z, so we don't want the 0.38, but we're okay with Y, and we're okay with everything else. So we're okay with the 0.13, we're okay with the 0.23, and we're okay with the 0.26. So 13 and 26 is 39, 49, 59, 62. Okay, so that's going to be 0.62. And then finally what we have is the probability of Z and not Y. Okay, the probability of Z and not Y. Okay, so what is that going to look like? The probability of Z, okay, and then not Y. I don't want any Y in there. So I've got the probability of Z is 0.38. But I can't include this part because that has Y in it. So it's just 0.38. Okay? So 0.38. So those are Venn diagrams.